Conditional probability is the probability of an event where the sample space is restricted to a specific outcome. It will be written like this. Find the probability of A given B. So the long line represents given. The probability of A given B. Again, as we read the phrase, the probability event A occurs given that event B occurs is written with the symbols. P of A line B. This is conditional probability, is probability of A given B. Let's do some of the problems. This story tells us that the table below categorizes the preferences of 300 students about their plans for prom. Suppose you pick a student at random from the class. Find each probability. A. The fact that they prefer hotels. So all of these students prefer hotels. That would be a total of 128 people out of 300 that prefer hotels. If we went with hip-hop, going straight across, probably that someone prefers hip-hop would be a total of 153 people out of the 300. Prefers hotel and prefers hip-hop band. So again, and tells you have to be in both categories, both hotel and hip-hop. That would be 73 out of the 300 people. Prefers hotels or hip-hop. This is a more challenging question. When we see or, it means we want to have one total or the other total, and watch out for if you might have counted people twice. So prefers hotels or hip-hop. We'll do all of the people who prefer hotels. That's 128 people out of 300. Or we can also include all the people who prefer hip-hop. That was our 153 people out of 300. But if you notice, when we went through hotels and through hip-hop, we had these people that this group of 73 got added into the total twice. So we want to take out those 73 that were in the total for both hip-hop and hotels. Subtract 73 to get our final probability. This is called the addition rule for OR, resulting in 208 out of the 300 people. Now we're finally on to the probability for the given conditions. For the probability that a person prefers hotels, given that they prefer hip-hop. This given hip-hop is what our restriction is. So we can only look at the hip-hop category. That's the only people we're considering. And we want to find the probability that someone prefers the hotel. So we would have 73 people that prefer hotels out of only the total of 153 people that liked hip-hop. So the hip-hop was our restricted population, and we wanted to find the probability that they prefer hotels. Let's try another one. The second one is the probability that a person prefers hip-hop band given they prefer hotels. So again, prefers hotels is our given restriction, so we can only consider the hotel category, nothing else. We know that there's 128 people total in the hotel category, and we want to find the people who prefer hip-hop. So those hip-hoppers would be 73 out of the total 128 people who liked hotels. Let's look at one more example. Don't worry about all the words, just take a look at the chart. Let's try to find the probability that a student is wearing sneakers given that the student is a girl. So the given restriction of girl means we can only consider the girls group. There are a total of 28 girls, and I want to look for the ones wearing sneakers. The probability that you're wearing sneakers is 10 out of 28. Now let's look at the second part of the question. How does that compare to the probability of someone just wearing sneakers? The probability of someone wearing sneakers is 15 out of the total number of people in this survey. So there are 15 people wearing sneakers, and if I total up all four categories, I'm going to end up with 42 people totally represented. So 15 out of the 42. How do these compare? They are not the same fraction. Even if I tried to reduce or converted them to decimal, these fractions are not the same. Therefore, these are not independent. The rule for something to be independent is that the probability of just A must equal the probability of A given the restriction of B. So if we compare the probability of wearing sneakers for A, it does not equal the probability of wearing sneakers given a restriction of girls, so they are not independent. For now, that's all we'll talk about for conditional probability, the given, and for independence.